Hey guys, well, here we go. Welcome to your first official remote learning video lesson. I thought what we would do today is just go back to the last time we had an in-person algebra class, which really was back on Friday, March 13th. We did have school that following Monday on March 16th, but so many students were absent we didn't cover any new material that Monday. So really the last, what I would say, regular day of class we had was on that Friday. And if you recall, we were in Unit 6 on Lesson 6. It was scientific notation, and it ended up being day 1 of that lesson. We had done adding and subtracting numbers that were written in scientific notation. So because we did these notes on the 13th, I thought it would be a good idea to go back, review what we did, and maybe fill in some of the blanks of some of the other problems that we didn't do, just as a way to kind of refresh your mind, refresh your memory for how to work with these scientific notation problems, at least for adding and subtracting. So what you're going to see here is a review. You probably have all of this written down. If you were in class on the 13th of March, which again was that Friday, chances are you already have this entire lesson or this part of the lesson in your notes. So it's about scientific notation. Remember, we're talking about how when you convert a number from standard form into scientific notation form, it's all about moving the decimal, right? And we reviewed how it's you have to count the number of jumps that the decimal has made from standard form to where the decimal would need to land, in this case between the 2 and the 8, in order to be in scientific notation format, and then that number of jumps becomes the exponent on the 10. So in this example, the number 284,000, the decimal is hiding out here at the end on the right. And we know that in scientific notation form, we need to move it so that our number in the highest place value is in the ones place, right? So you got to move it all the way over here between the 2 and the 8, and that ends up being 5 jumps. So it's 2.84 times 10 to the 5th. It's not about counting zeros, right? It's about moving the decimal. Then we went on and we converted the other way. We started with a number that was in scientific notation. I'm sorry, I take it back. We didn't get there yet. This is another standard form, but this is what I was calling a teeny tiny microscopically small decimal number. And so again, it's all about moving the decimal. Here's the decimal. Where do we want it to be for scientific notation? Well, it would need to land here so that you had a number in the ones place and nothing larger than the ones place. So then it would become 2.68, right? So there's that 2.68. Now, again, it's counting those jumps. How many jumps did that decimal have to make? It made 6 jumps. And that becomes the exponent on the 10, except it actually is a negative 6. So back in class all those weeks ago, we were remembering that when numbers are in standard form and they're what I call microscopically small decimal values, when you convert those to scientific form, that's when you get that negative exponent. Whereas up here, we had a number that was in high in value, right? This is 284,000. And that then created a positive exponent on that 10. So then we practiced with a few, right? We did these. You probably have these all in your notes. But let's do those other 2 problems that we didn't solve. So for number 3, it's 907,000. The decimal is currently hiding here. We want it to move here between the 9 and the 0. So we're going to count those jumps. It's 1, 2, 3, 4, 5 jumps. And my new number then would be 9.07 times 10. And because that was a high value number to start with, it's going to be a positive 5 exponent. The only other one we didn't do here was number 5. The number starts out as 0.04 or 4 hundredths. That's a microscopically small decimal number. I see the decimal there now, But for good scientific form, I need to move it so that I have a digit in the ones place. That's going to move it right there. How many jumps is that? That's 1, 2 jumps. So my new number is 4 times 10, and it's to the negative 2, right? Negative 2 because it was microscopically small to start with. Okay. Then we went the other way. We started in scientific and we converted back into standard form. So that's what this is. Be patient here as I try to figure out this camera placement, right? It's not easy to record lessons at home, which, by the way, I'm at home. So you're going to hear my dog bark. You might hear my kids talk from time to time. That's just the reality of the situation. Anyway, let's go the other way. Let's start in scientific and move to standard. Again, it's all about the decimal, and it's all about the exponent, which this appears to be a little bit blurry on here. I'm so sorry. I'll try to autofocus. Maybe that'll help. No, that didn't help at all. Well, you're just going to have to listen. I'll try to tell you what these numbers are. So, for example, number 9 here, we didn't do this one together, so let's do it now. It starts as 1.14, or 1 and 14 hundredths, times 10 to the third. That's a positive 3 right there. So that exponent tells me I need to make that decimal jump 3 times, and because it's positive, I need to be creating a larger number. Decimal's going to move to the right. So 3 jumps would go 1, 2, 3, which would actually leave a gap. So the number would be 1, 1, 4, and then you fill in the gap with a 0. And if you care to, you can go back and add the comma. That's 1,140. And this one, even more difficult to see, but here's what it says. 3.8 times 10 to the negative 1. So the negative 1 means you're creating a smaller value number. You're going to move that decimal 1 jump to the left this time. So here's the decimal now between the 3 and the 8. We're going to bounce it 1 jump to the left over there. So it's going to look like 0.38. And of course, throw that 0 in there. So it actually says 0.38 or 38 hundredths. All right? Good. Now, that was converting to scientific notation form and then out of scientific notation form. But then we did adding and subtracting. Adding and subtracting. Let's see if this gets any better. Does this help? What does that do? Oh, no, that makes it worse. What does this do? No, that doesn't do anything. All right, well, we're just experimenting here. We added and we subtracted, and the thing about adding and subtracting is that you have to make sure the exponents are the same on your tens, right? So if they're not the same, we have to adjust the numbers. So for example, I know it's really hard to see, but this says 3.4 times 10 to the second plus 5.2 times 10 to the second. So they're both 10 to the second. That means you're good to go. So then you just do the math part. You take the 3.4, add the 5.2. That's where we got our 8.6. And then it just stays times 10 to the second. So if you have matching terms here, then that's awesome. You can just do the simple adding or subtracting of the decimals, and then notice it stays 10 to the second. So that's cool. However, it gets a little bit tricky when the exponents aren't the same. And I know you're looking at this going, I have no idea what that exponent is, Ms. Glessner. It's so tiny. I know. I'll tell you. This was 9.5 times 10 to the 7th plus 1.1 times 10 to the 6th. Ugh, that's a 6 and that's a 7. So here is an excellent example of one that we need to convert. If you missed it when we talked about this in class, please hear me now and please put this in your notes. When you're adding and subtracting like this, and you need to tweak one of these numbers, like this, are we going to make this a 10 to the 6th or are we going to make this a 10 to the 7th? The deal is you always want to convert it into the higher power. Okay, so in this case, 10 to the 7th is more than 10 to the 6th. So this guy is going to become a 10 to the 7th. Now, we talked about this idea of LARS. That stands for move it to the left if you're adding to the exponent, and move it to the right if you're subtracting from the exponent. So we need to get from an exponent of 6 to an exponent of 7. So we're going to be adding to the exponent. That means we need to move the decimal to the left. So instead of 1.1, we move the decimal to the left, and it became 0.11 times 10 to the 7th. So we are adding 1 to the exponent, which means you take your decimal and it needs to move to the left. Okay, so then we did our math, and 9.5 plus 0.11 was 9.61, 10 to the 7th, 10 to the 7th, 10 to the 7th. Okay, let's do some that we didn't do during class. Here's one. I really, really wish I could zoom in. Let me see if I can zoom in a little bit. Hold on. You must learn to be patient with me. I'm telling you, you gotta be patient. Okay, that definitely makes it bigger, but it's not any clearer. Let me try this. What's that do? Autofocus? No. How about this button? Bummer. That just does not help. What's that say? What's that say? Lock it in. Garbage. Dang. Well, kids, I don't know what to tell you. This is really the best we're going to be able to do right now. I'm going to zoom out a little bit. Okay, I'm so sorry. Well, here we go. 6.8, that's 10 to the negative 3. Plus 2.7, 10 to the negative 2. Maybe I'll rewrite it. Would that help? That helps a little bit. Adding. Well, that might be a little bit better. It just doesn't like it. I don't know. It's just not the best quality. I'm so sorry. Okay, so we have a negative 3 and a negative 2. Which one is a larger value? And when they're negative, be careful, right? Because it's actually the negative 2 is larger than negative 3. Okay, so this is the guy that needs to be changed. We're going to change him to a 10 to the negative 2. So to get from a negative 3 to a negative 2, you're adding, right? And when we add, that's when we move our decimal to the left. So it's going to go from a 6.8, one jump to the left, 0.68 times 10 to the negative 2. Add 2.7 times 10 to the negative 2. So now we take our 0.68 plus 2.7, and that's going to give us 3.38 times 10 to the negative 2. Final answer. All right? So it's all about adjusting those exponents. And to get from a negative 3 to a negative 2, you have to add 1. And remember LARS, up here, when you're adding, you move the decimal to the left. If we were subtracting to adjust the exponent, we would move the decimal to the right. In this case, we were adding, so we moved the decimal from where it was, one jump over, so it became 0.68. Okay? Okay, guess what? Don't forget this is a review. Probably doesn't feel much like a review. It probably feels something more like torture. That's all right. Okay, let's do some more, and then we'll be done. We just have a few more examples. All right. You know what? I'm just going to rewrite it. 1.83 times 10 to the negative 4. Adding 7.32 times 10 to the negative 3. Okay, they don't match. I have a negative 4 and a negative 3. Which one's bigger? Negative 3. So we're going to convert the negative 4 to a negative 3. you have to add 1. Remember, when you're adding, decimal moves left. When you're subtracting, the decimal moves right. Okay, so we're adding, decimal moves left. 0.183 plus 7.32 times 10 to the negative 3. Nothing changed on that one. So now you just grab your handy dandy calculator and you take 0.183 plus 7.32 equals 7.503 times 10 to the negative 3rd. Okay? Good. I'm going to try writing in pencil. Let me see how that works. Here we go, this one. It says 7.59 times 10 to the negative 2 minus 2.32 times 10 to the negative 2. Yay, they matched! 10, negative 2, 10, negative 2. Oh, this is an easy one. All we have to do now is subtract. 7.59, subtract 2.32. We end up with 5.27 times 10 to the negative 2. Yay, that one was easy. We didn't have to adjust anything. I think the marker's better, don't you? I don't know. Neither one of them is great. Well, we'll do what we can do. Okay, guys, 2 more. We have 4.22 times 10 to the negative 6. Subtract from that 6.8 times 10 to the negative 7. Boo, they don't match. A negative 6 and a negative 7, which one's larger? The negative 6. So we're going to adjust this guy to be a negative 6. How do you get from a negative 7 to a negative 6? You add 1. Adding moves left. So 6.8 becomes 0.68. Nothing here changes. Now that they match, you can take your 4.22 minus 0.68. We end up with, final answer, 3.54 times 10 to the negative 6. Okay, so once you get the 10 with the exponent, right, once you get those parts to match, those terms, it just becomes a quick math problem. In this case, you're just subtracting 2 decimals. Okay, last one. Let's finish strong. 5.3 times 10 to the negative 1, subtract 2.7 times 10 to the negative 2. They do not match. This one's bigger. This one needs to be adjusted. How do you get from a negative 2 to a negative 1? You add 1. Anytime you're adding, you move left. So 2.7 becomes 0.27. Nothing's changing here. And don't forget you're subtracting. So basically now take your 5.3, subtract 0.27. Look what you get. 5.03 times 10 to the negative 1. All right. So that was a review. And is this strange? Extremely strange. The whole thing is strange, right? But we're not gonna try to concentrate on that too much. We're gonna try to focus on that. We basically just have to find our new normal, right? And this is it. This is our new normal. This is how it's gonna be. Let me give you some information about your assignment. So this assignment, Unit 6, Lesson 6, Scientific Notation, Day 1, Problems 1 through 18. This is going to be in Google Classroom. Chances are you probably already have this done because it was originally signed on 3/13. Now, when is it due? It's going to be due tomorrow on Wednesday, April 8th. And I know you're thinking, how in the world am I supposed to turn my assignment in, Ms. Glessner? Well, remember what I said, it's the new normal. We have to find a way to do this, to make this work as best as we can. Here's what I've come up with. When your assignment is completed, I'm asking you to upload a picture of your assignment into Google Drive. So what you're going to see now when you get into our Google Classroom, oh, it shouldn't say Google Drive. That should say Google Classroom. Oh, for the love of God. Google Classroom. When you click in, what you're going to see is I've created a doc. And I've made a copy of it and shared it with all of you. My guess is you guys are used to doing this in other classes. So you're going to take a picture of your assignment, and you're going to upload it into the doc that I've posted in Google Drive. No, in Google Classroom. And once you post it there, I'll be able to see. You know, you'll turn it in electronically. I'll get to see it. And when I see that you have your assignment completed, I'll check it, you know, real quick, make sure it looks like you're doing things right. And then you basically get credit or no credit. If you've done the 18 problems, you get credit. It's almost like pass or fail, except the terminology we're using is pass or incomplete. So as long as you're doing your assignments entirely and you're turning them in to me electronically, I will keep a list of which assignments you've handed in. And if you're engaging with me on a regular basis and I can tell that you're watching these videos and I can see that you're submitting your assignments as I ask you to, then you're going to pass. It's that simple. What does an incomplete look like? Well, that's the kid who never does anything. You're not watching these videos, you're not attempting to do the work, and you're just going to get an incomplete. So remember, video viewing and assignment completion are now graded as pass or incomplete. All right? Now, are we always going to have this many problems? No, we're not. I only left it as 1 through 18 because it was previously assigned as 1 through 18. What we're going to do moving forward is we're going to go much slower. We are certainly not going to be able to hit all of the normal content that we would have covered if we were sitting in our classroom together every day. But again, it's the new normal. We're going to do what we can do the best that we can. My goal for you is that you're going to keep turning on your math brain and you're going to keep thinking about math, and that I'm at least going to get the opportunity to show you some of these concepts because we do have a lot of important things we have left to cover. And I want you to see them before you roll into the high school next year, all right? So thank you so much for watching, and thank you so much for your patience. And I really look forward to finding our new normal right along with you, all right? Take care, and be in touch as needed. Thank you.